Hello and welcome to Amit's Tech Sessions. My name is Amit and I'm a software architect. In this session, I will talk about step-up authentication, how it works, what are its use cases and benefits, how it can be implemented, and finally, I will walk through an AWS reference architecture for step-up authentication. So let's understand what is step-up authentication. Step-up authentication is an authentication process where user is challenged to provide an additional form of authentication. So it is a way to strike the balance between the security and the friction. Step-up authentication ensures that users can access some resources with one set of credentials, but will prompt them for more credentials when they request access to sensitive resources. Step-up authentication provides increased security by requiring more verification when certain risk thresholds are met. So this ensures that access is granted only after the user's identity is sufficiently verified. Let's understand step-up authentication with a simple example. When you log in into your internet banking, you perform initial authentication using username and password. After initial authentication, you can view account summary, account balance, and any other non-sensitive information. When you start transferring money to a new payee, for example, you are triggered for a step of authentication by the bank. Bank does this because bank believes that transferring money is a sensitive or risk-based operation, and that is the reason it asks for another form of authentication. You then, for example, enter the code and then transfer gets successful. So this is a simple example of step-up authentication. So let's understand how step-up authentication works. Step-up authentication uses a mechanism called adaptive authentication, which is also called risk-based authentication. Adaptive authentication or risk-based authentication works by creating a profile for each user, which includes information such as user's geographical location, registered devices, role, and any more information. Each time someone tries to authenticate, the request is evaluated and assigned a risk score. And depending on the risk score, the user may be required to provide additional credentials or conversely allowed to use fewer credentials. So this authentication method delivers zero trust and improves the security. In adaptive or risk-based authentication, there are three different risk levels which are defined: low risk, medium risk, and high risk. Based on these three risk levels, appropriate step-up action is triggered. For example, let's say your profile says that you are based in Ireland, but you are performing a transaction from location of somewhere far in the world. Then system thinks that this is a high risk transaction and it triggers a step-up action. If I explain this with a flowchart, so when user attempts an action, the system performs a risk assessment. Then risk assessment outcome is checked. If risk assessment outcome is low, then no extra authentication is triggered and action is completed. If risk assessment outcome is high, then system requests additional authentication. User then performs step-up authentication. By the way, a simple technique used for step-up authentication is multi-factor authentication. So if in this case, multi-factor validation is successful, then action is completed. If multi-factor authentication validation is not successful, then action is failed. Pretty simple flow of the step of authentication process. Now let's understand the value proposition of step-up authentication. So step-up authentication provides improved security. It provides an extra layer of protection when necessary, which reduces the risk of unauthorized access. Also, it adapts to the threat level dynamically, which offers better protection better protection against the sophisticated attacks. So, step-up authentication also provides better user experience by minimizing the friction, uh, by requiring additional verification only when needed. So it also maintains a balance between security and usability, which reduces the user frustration. Step-up authentication also helps organizations meet stringent security standards and regulations like GDPR, PCI DSS, and PSD2, etc. So it also reduces the risk of penalties and reputational damage which is associated with data breaches. Step-up authentication lowers the cost of fraud and unauthorized access by preventing high-risk actions from being executed without verification. It also avoids the need for always on high friction security measures. AWS provides a reference architecture for the organizations on how they can implement a step-up authentication using AWS services. And this is, by the way, just a reference architecture. I will walk this through step by step. However, you don't need to use this reference architecture for your step-up authentication implementation. You can choose a different architecture or decide which one you want to use. So let's discuss this reference architecture step by step. So in step 1, initially the client application authenticates using Amazon Cognito. As a result, that client application gets a valid access token, which is generated by Amazon Cognito user pool. Now, step 2, the client application invokes the privileged API action, and privileged API action could be a transfer money, for example. And then client application passes the access token in the authorization header for that privileged API call. In step 3, this privileged API action is protected by using a Lambda authorizer. This authorizer first validates the token by invoking the Amazon Cognito user pool public key. If the token is invalid, then 401 unauthorized response status code is sent immediately, which prompts the client application to present a valid token. In step 4, the authorizer performs a lookup in the DynamoDB settings table to check whether the current request needs elevated privileges or not. So in the settings table, you can define which API actions require elevated privilege. You can additionally bundle multiple API operations into a group by defining like the group attribute. So this allows you to further isolate privileged API operations, especially in the large scale deployment. In step 5, if an API action requires elevated privilege, then the Lambda authorizer will check for an existing step-up session for that specific user in the sessions table. So if a step-up session does not exist, the authorizer will create a new entry in the sessions table. And the key for this table will be the GTI claim of that access token which was passed by the user. In step 6, if a valid session exists, then authorization will be given. Otherwise, an unauthorized access response, which is 401 HTTP code, will be sent back from the Lambda authorizer, indicating that the user requires elevated privilege. In step 7, then client application initiates the step-up action by calling an initiate auth endpoint. And this action is protected by the API gateway built in Amazon Cognito authorizer. And then the client needs to pass a valid access token in the authorization header. In step 8, this call is forwarded to a Lambda function that will initiate the step-up action with the end user. The function first calls the Amazon Cognito API action getUser to find out the user's MFA settings, and depending on the MFA type, the function uses different Amazon Cognito API operations to start the MFA challenge. In step 9, the client application then presents an appropriate screen to the user to collect that response for the step-up challenge. Client application calls the respond to challenge endpoint, and the request which is sent to this endpoint includes an access token in the authorization header. A step-up challenge type is also included, and the response which is provided by the user to that step-up challenge, which could be a 8-digit code or 4-digit code or whatever. In step 10, the call is forwarded to the Lambda function, which verifies the response by calling the Amazon Cognito API action verify user attribute in case of SMS step up, or verify software token in case of the software token step up. So depending on the type of step up action which is written from the initiate auth API action. So Cognito response will then indicate whether the verification was successful or not. So in step 11, if the Cognito response in the previous step was successful, then the Lambda function associated with respond to challenge endpoint inserts a record into the sessions table by using the access token JTI as key. And this record indicates that user has completed step-up authentication. The record is inserted with a time to live. The respond to challenge endpoint then returns a 200 status code after successfully updating the session table. It returns a 40 unauthorized response code if the operation is failed or if any of the Amazon Cognito API calls in the previous steps are failed. In step 12, finally, the client application then retries the original call to the privileged API operation. And then this call now should succeed because an active step-up session exists for the user. Calls to other privileged API operations that require step-up should also succeed as long as the step-up session hasn't expired. So this was an overall flow of a reference architecture which is provided by AWS. It is available on the internet. You can also download the code base as is from the GitHub repository. That's all I have for this video. I hope this was useful. If you would like to connect with me on LinkedIn or Medium, there are QR codes up on the screen. Thank you. Thanks very much.